So, what we've done so far is we've looked at in the previous 8 parts what a percentage is, how you find a percentage with a calculator and without, how you do increases and decreases, and then how you reverse them. What we haven't done is looked at this situation. So, go back to my favourite t-shirt. It costs £20. In the sale, it's reduced to £15. What is the percentage decrease? So before, we were applying an operation, like for example, a 10% decrease, to get an answer. Or we were doing a reverse percentage where we knew what the decrease was, and then we had to work it backwards to find the original value. Because in the question it gave us the current and asked us for the past. How am I going to work out the multiplier here? Well, that's what I need. I need to know what this has been multiplied by. I think it's 0 point something. Why do I think that? Well, I think it because 15 is smaller than 20. So it's definitely a decrease. Okay, if I gave you 2 and 6, what's the multiplier? That's right, it's multiplied by 3. So it's divide by 3. What happens if I do this divided by this? Aha! It gives me the multiplier. So, this divided by this gives me 0.75. So that's the multiplier they've applied, which gives me a decrease of 25%. Okay, so if we know the two values, the future divided by the past will give me the multiplier, and then I use this to work out what percentage I've got left and then what the decrease or increase must have been. So let's go back to the house, which is going to start at 150,000 and increase to 180,000. So I already know it's multiplied by 1 point something because it's increasing. So I do my divide, and when I put it into the calculator I'll leave all the zeros off, and I get 1.2, which is 120%. So the increase is 20%. So what I'm doing here is I'm taking the new value and dividing it by the old value, and I'm getting the multiplier. And then I'm converting the multiplier into a percentage, and then I'm noting the percentage increase or decrease. So, doing the new divided by old, converting to a multiplier, and then noting the increase or decrease. New divided by old, converting to a multiplier and then into a percentage, noting the increase and decrease. So all of a sudden, this method is starting to make a lot of sense, hopefully. And those 3 steps will guide us through some questions. Now, we've covered an awful lot of percentages. We've just got some very tricky examples of finding the percentage increase and decrease to do. Because whilst with one step like this, it's very easy, we've then got to look at what happens if we have multiple increases. So, a house starts at 180,000 and after 2 years its value has increased by the same percentage each year and its value is now 220,000. So what was the percentage increase each year? So I'm going to just write 180 and 220 here, and rather than drawing one big arrow, what should I draw? So 1, 2. And these are the same number. So I'm going to call it K. So let's have a go at this using our method. New divided by old equals multiplier. Well, actually, it's not going to be the multiplier. It's going to be the multiplier squared, because we've got to do it twice. So 220 divided by 180. So my calculator tells me that is 1.2 recurring. Okay, little note there, you can see there's a small dot here above the 2, which means it's 1.2 recurring. If you press S to D, you'll see that. So that is the multiplier squared. So K squared equals 1.2 recurring. So the question is, how do I find the actual multiplier? Well, I'm going to square root that answer. And if I press the A and S button, the answer button, it will use the 1.2 recurring. Hit equals, and I get a complicated answer which I can convert to a decimal with S to D. And it gives me 1.10554, and then I'm going to put 3 dots because the number carries on. So, what is my percentage increase? Well, I'm going to go for 3 figures. This is 10%. I want to have point something percent for my increase. But the 5 after that says round this 5 up. So it's 10.6% increase per year, or if you want the fancy word, per annum. And remember that is to 3 decimal places or 3 significant figures. So, hopefully that's made sense. You may find here that if you had 5 years, this would be k to the power of 5. Then you'd have to do the 5th root to find this. But the process is the same, it's just the power that changes. Let's look at one more question. Okay, and this is tied in with the idea of percentages. After how many years of increasing at 5% will a value double? Well, we don't know what the value is, so we call it 1, and we times it by 1.05 to increase it. Now we don't want to do it just once, we don't know how many times to do it, so we want to put here, could be any number, I'm going to call it n. Now we want the value to double, so we want the value to come out as 2. So a reminder of what we did previously, I'm going to go 1.05, that's 2 years, that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So n equals 15 and you get 207.9% of the original. So be prepared to play around with powers here in both respects. Now that's percentages as a standalone topic. We've now got to link it with fractions, decimals and percentages and converting between the three. And if you've done this comfortably, you'll certainly enjoy that.